Alright, so this is going to cover an example of using the irrational conjugate theorem. Now the irrational conjugate theorem, basically what we're doing here is we're going to, as it says in the book 41 through 46, write a polynomial function of f of the least degree that has the leading coefficient of 1 and the given 0. So here are our given zeros. Now we're given two zeros here, but one of our zeros is an irrational number. So 6 minus the square root of 7 is an irrational number because this right here. Square root of 7 is an irrational number. If you guys were to go to a calculator and type in the square root of 7, so if we do the square root of 7, that number there is irrational because of all the, there's no pattern, there's no stop to the decimal. It's 2.645751311. That decimal isn't repeated and it's not going to stop. It actually keeps going. That's an irrational number. Okay, so we have an irrational number here. Now, what the irrational conjugate theorem says is that if this irrational number is a 0, well, there's actually another 0 like that, which would be its conjugate. Now, the conjugate to 6 minus the square root of 7 would be 6 plus the square root of 7. So the problem only gave me these two, but the irrational conjugate theorem says, hey, if this is a 0, then its conjugate 6 plus the square root of 7 is also going to be a 0 of the polynomial. Okay, so that's the irrational conjugate theorem. Now, if we're going to if we're going to find a polynomial, which is what it wants us to do, so it wants us to write the polynomial. Okay, this is what I would do. So here's the thing: we know that x is equal to 4. We know that x is equal to 6 minus the square root of 7. And x is equal to 6 plus the square root of 7. These are the solutions. Well, let's just work backwards, kind of just like what we did up in previous problems. So we solved 4x here. Well, let's go backwards. Let's set these equal to 0, set these up in factors, multiply, and get our original solution. So that's essentially what we're going to do. So I'm going to subtract 4 from both sides over here, and I get that x minus 4 is equal to 0. So x minus 4 is a factor. Here, I'll do x, I'll subtract the 6 and add the square root of 7. So I get x minus 6 plus the square root of 7, and that's going to be equal to 0. Likewise here, x minus 6 minus the square root of 7 is equal to 0. Now let's go ahead and take my factors and write them together. So x minus 4 multiplied by x minus 6 plus the square root of 7, and then x minus 6 minus the square root of 7. So these are my factors here. I can multiply them now. Now, whenever I have conjugates, always multiply the conjugates together first. So that's this factor here and this factor here. Multiply these conjugates first, and I promise you, you'll have a much easier time. So I'm going to use the properties of multiplying polynomials. So I'll do the FOIL method of x times x, x times negative 6, and so on and so forth. So x times by x is x squared. X times by negative 6 is negative 6x, and then minus square root of 7x. Okay, I'll do next negative 6 times all three of these. So negative 6 times negative 6 is positive 36. Negative 6. Oh, I forgot to multiply by the x first. Hold on. So negative 6 times by x, which would be a negative 6x. I'll line up with that term. Negative 6 times negative 6 would be positive 36. And then I'll have negative 6 times negative 7, square root of 7. So that would be, I'll just call that plus 6 square root of 7. Okay, And then last, I'll take the square root of 7. So the square root of 7 times x would be positive 7 square root of positive square root of 7x. I'm going to put that here because they are like terms. Okay, and then I'll do square root of 7 times by negative 6, which would be negative 6 square root of 7. I'll line that up here because they're like terms. And then negative or positive square root of 7 times by negative square root of 7. Well, square root of 7 times by negative square root of 7. I'll put the negative out here because it doesn't really matter the order. So it'd be negative square root of 7 times 7, which would be negative square root of 49, which would just be negative 7. So minus 7 here. And let's go ahead and add up our terms. So we have x squared minus 12x. Those cancel. Those cancel. And then I'll be left with 36 minus 7, which will give me 29. So plus 29. And there you go. So, not finished yet, sorry. That's whenever we multiplied those together. Now, don't forget that I have to multiply it by x minus 4. So I have x minus 4, x squared minus 12x plus 29. Now, notice that I don't have any more irrational numbers. I don't have any more radicals. That's because I multiplied the conjugates together. When you multiply conjugates together, these radicals will actually cancel out. Okay? So always multiply conjugates together first. Okay, now here I'll do this. So x times x squared, which would be x cubed. X times negative 12 x would be negative 12x squared. And x times by 29 would be positive 29x. Okay, and then negative 4 times by all of these, so I'll have negative 4x squared plus 48x, and then that would be minus 4 times 29, which is 116. Add them together, I get x cubed minus 16x squared. 29 plus 48, 77, minus 116. And that would be our polynomial function of the least degree possible. Leading coefficient is 1, and I used the given zeros, which were up here. Okay, so hopefully that should give you a boost on trying to solve problems like this.